Hello my dear friends, welcome to IMS GATE Academy. So yesterday we were learning the concept of convection, and today I am going to continue on the same page where we have left yesterday. So yesterday, let me remind you that yesterday we did the concept of forced convection, and today what we will do, we will first some part of forced convection is left. Yesterday the discussion was only of the flat plates, but today we will learn about the internal flow, that is the flow through pipes concept, that is how heat transfer is taking place, what are the various cases that is being developed, and after that we will also see the concept of free convection or natural convection, right. So without wasting any time, let us quickly come to the concept. So today's topic will be or I should write forced convection through pipes. Right. Now my dear friends, I will try to explain you what phenomenon is actually happening. Pipe means hollow cylinder, then only something will flow. So imagine that this is a pipe of length L, diameter D, ठीक है, and it is hot, it is a very hot pipe, it is maintaining a surface temperature Ts, right, and from here you know some liquid is made to pass. So it will exit, this is the inlet and this is the exit. Let us say that the temperature at the inlet is Ti and the temperature at the exit is Te. Now what will happen? Suppose the pipe is hot, so when the fluid comes over and when it comes in contact with the surface, the temperature of the fluid will rise, and then as it flows, its temperature keeps on rising, and ultimately its temperature becomes the maximum at the exit. This is the thing. Let us say the surface temperature is 100 degrees centigrade. So initially it will be, let us say, 30 degrees centigrade, and as it exits the pipe, it will be somewhere around, let us say, 80 degrees centigrade. That means what we are seeing that the temperature of the fluid is changing. That we can confirm that the temperature of the fluid is varying. One more thing, my dear friends, you would feel that, sir, the fluid particle which is near the surface, it should have a higher temperature as compared to the particle which is at the center. Why? Because the particle when it is in direct contact, its energy will be more as compared to the particle which is at the center. Yes, correct only. And we have seen that a profile somewhat like this develops, and this I am saying at a particular section this is happening. This is happening at a particular section, that at the surface temperature is maximum and at the center point the temperature is minimum. This is the profile that develops, or the layer, boundary layer we can say, concept develops over here. We should not be surprised, because when you learn fluid mechanics, in there also you see that this is the kind of velocity profile that develops. In your FM also, in fluid mechanics also, we have seen this concept that the velocity increases as we go towards the center. So similar to that, the temperature profile also develops. Okay, Anuj Sharma, sir, please provide numerical on thermodynamics entry length in pipeline. Okay, Anuj, when any teacher will discuss about the thermodynamics, so we will try to include that concept. So as you have requested, we will try to include that concept when we start the question series. We will see. Okay, fine. As of now, this is the most expected concept series. So this is the concept that we are discussing. Questions might be discussed after some time. Okay. So what I am saying is that once we know, now we know that the temperature of the fluid is varying. Now one issue is there. If someone tells you or asks you that, okay, at this section where you have drawn the profile, I want to know what is the temperature of the fluid. So what will you tell? So here you can see that the temperature is varying. So if someone asks you one single temperature just for the mathematical purpose, what will you tell? We will not be able to say anything. For that purpose, what we do, we take, there is a concept of mean temperature of the fluid. Mean temperature of the fluid, we take the mean temperature. How we calculate the mean temperature, that is a separate topic. But we take the mean temperature everywhere across the length of the pipe. Why? For the mathematical purpose. When someone will ask you, okay, at this section, you just tell me what is the heat transfer. So first you will see what is the temperature of the fluid. First of all, you should know that heat is getting transferred between what? Heat is getting transferred between the surface of the pipe and the fluid. So del T is there. Del T is there. Del T will be taken. So del T ke liye surface temperature is there. Okay, sir. What will be the fluid temperature? You will say that the fluid temperature is varying. So for that purpose, we take mean temperature of the fluid. And although the profile is parabolic in nature, but moving forward, I will have to convert it in terms of mean temperature. Mean temperature matlab constant temperature, so that at every section you will have one temperature of the fluid, right? So let me again show you that what I am trying to say. This is the pipe. Now at the inlet, no issue is there, because I can consider all the temperature at all the planes to be mean temperature. So I can say mean temperature at inlet. At the exit also, no contact with surface is there. So I can say that it is the mean temperature at outlet. Something like this. Improve. Why I have shown with increased length? Because temperature have increased. Okay. And when it is passing through every section, I will not show the exact or the correct profile, the real profile. Rather, I will show it with constant lines. Why I have showing with constant lines? Because I will have to consider one single temperature at every plane. For example, this is, let's say, 30 degrees centigrade, this is 40 degrees centigrade, this is 50 degrees centigrade, this is, let's say, 80 degrees centigrade. But everywhere I am showing the mean temperature. At every plane, at every position from the surface, the temperature is constant. Getting? So this is the concept of mean temperature of the fluid. Mean temperature. How we are finding, that is a separate topic. Okay. So I think the lines have got a bit tilted. So don't focus on that. Focus on the concepts. Okay. Now at any position from here, from x equal to 0, this is the length L of the pipe. At any position, if someone asks you what is the heat transfer, so what will you tell? You will tell, sir, Q. As a fluid is there, it is taking heat from the surface. That means it is the case of convection. It is the case of convection. That means Newton's law of cooling you will apply. Okay, very good. So H A delta T. What is delta T? From surface it is happening. So let's say from surface, and I am considering that at any position, at any distance from at any x, the temperature of the fluid, the mean temperature I should say, Tm. So why I am writing Tm? Because I have to consider the mean temperature, and that is what I have shown by constant lines. Okay. So Q by H I can write Q by H, not Q by H, Q by A is equal to H Ts minus Tm, and so I can write Q by A as small q, that is the heat flux, as H, and this is Ts minus Tm. Very good, sir. What is this? This is the heat flux. This is the heat flux at any distance x. Okay. So from here what I can write, Q by H is equal to Ts minus Tm, or I can write that Tm is equal to Ts minus Q by H. At any distance x, what is the heat transfer? This is the heat transfer. Okay. What is Tm? Mean temperature of the fluid. Okay. Now you know that this Tm is varying. This Tm is varying, and after some time you will know that, or rather you know itself, that H generally we take a constant value. H, although it changes with position, but later on there will be a concept that for a fully developed region, the H value, for a fully developed flow, the H value remains constant. So this is constant, this is constant. Now suppose that if Ts will vary, if Ts is also constant and Q is also constant, just imagine that Ts and Q both are constant. So will the left hand side be constant? No, left hand side will not be constant. Why? Because if everything is constant, how will this means if everything is constant, if everything is constant, then Tm will remain constant. And by our discussion over here, we know from the very basics of concept that Tm has to vary. Tm has to vary. Very good evening, Nikhil. Tm has to vary. So that means both cannot be constant at the same time. It means when Ts is constant, somehow Q will vary, or when Q is constant, somehow Ts will vary. That means both cannot be constant at the same time. Some on the other one of them must vary. If Q is constant, Ts will vary. If Ts is constant, Q will vary. Right? So therefore, now we are going to study two cases, and those two cases is, one time I will take Q as constant and once I will take surface temperature as constant. What is Q? Heat flux. What is Ts? Surface temperature of the pipe. And what is H? Heat transfer coefficient. Right? So I hope this concept is clear, that why we are going to study two cases right now. Very good. So case 1 is constant heat flux. Constant heat flux, that is Q is equal to constant. Achha, what is the unit of heat flux? Watt per meter square. Watt per meter square is the unit of the heat flux. Okay. So let us take, achha, when I am analyzing this, what is my objective? What is my objective when I am analyzing this? Although everything will be clear after some time, but you want to know that okay, Tm is varying. but what is the nature of variation, how it is varying, is it varying quadratically, is it varying linearly, cubically, exponentially, all these things you want to see, right? Okay. And finally, what is the heat transfer? What is the heat transfer? No, this is for fluid inside pipe. See, H is for, we are talking about inside flow. We are talking about inside flow, okay? Internal flow we are talking about, and H depends on a lot of factors. Yes, H depends for a fluid, yes, inside pipe, and it depends on a lot of factors, correct. Internal flow, Anuj, internal flow. Okay. So let's say that the mean temperature over here is Tmi, and mean temperature over here is Tm exit, Tme. Now at any x, I want to analyze. At any x, I want to analyze. And when Q is constant, that means heat flux is constant. Heat flux is constant, that means I can assume one case. I can assume a case that kind of, wire, electrical wire wound. Electrical wire wound across the pipe. Then only this constant heat flux case will come. Electrical wire wound across the pipe. Now tell me one thing. Tmi is the inlet and Tme is the exit, and this is the temperature rise. I am considering a case of heating. So for example, the fluid is at 30 degrees centigrade. After heating, it will become, let's say, 80 degrees centigrade, or it can be cooling also, but just for the understanding, easier understanding, just assume that the fluid is being heated. Okay. So what is the net energy absorbed by the fluid? When fluid temperature is increasing, it means that the fluid is absorbing heat from the surface, from the pipe. So what is the total heat that the fluid is absorbing? It is m dot, obviously m dot now. Why? Because fluid is flowing, so dot will come, m dot C, and it will be Tm exit minus Tm inlet. This is the total heat taken by the fluid. Okay. Now at a particular distance x, I am assuming that the mean temperature of the fluid is Tm. I am assuming that the mean temperature of the fluid is Tm. Okay, very good. As of now, I am keeping Ts out of the equation. I am assuming Tm is the mean temperature of the fluid. Now tell me one thing, at any x from left, what is the, if the fluid is having a mean temperature Tm, the initial temperature was Tmi, so how much heat it has taken? It has taken m dot C, Cp also you can write, m, because constant pressure process only it is happening, m dot, I can write Tm minus Tmi. Very good, sir. And whatever heat is being given by the wire which is wound around, that is only resulting it in the increase in temperature. I repeat again, till the x, whatever wire has been wound around, whatever energy is being given by the wire, the same energy is resulting in the increase in the temperature of the fluid. So if I ask you what is the total energy supplied, so Q is constant, this is heat flux into area. And what is the area? Till x distance, what is the area of the wire? Let's say the diameter is d, the diameter is d, so pi d into x, pi d circumference into length x. So this becomes area into heat flux. Now whatever heat is being given by the wire, the same is resulting in the increase in the temperature, right? So both I can very easily equate, both I can very easily equate. So q into pi dx is equal to m dot c Tm minus Tmi. ठीक है सर, okay. Now this is the equation that we are getting. This is the equation that we are getting. Now carefully see this equation. Carefully see this equation. What is Tmi? Tmi is the temperature of the fluid at the inlet. So this is constant. Mc, they are also constant. Mass flow rate we will take constant. Specific heat capacity also will take constant. You are already doing the case of constant heat flux. So Q is also constant. Pi is a constant term, D is a constant term. So what is the only variable? X is the only variable, rest are all constant. And over here Tm is there. So if someone asks you what is the variation of Tm with X, this is what we intend to find out, yes or no? This is what our intention was, that what is the variation, how Tm is varying. So this is constant, this is constant. So I can say very easily that Tm is linearly dependent on x. I can write Tm as A plus Bx. Tm is proportional to x. It is linearly so good evening Abhinav, good evening. Thank you for the words. Yes, I remember. So Tm is proportional to x. Tm is proportional to x. So when Tm is proportional to x, this is the linear variation. So if someone asks you that how Tm is going to vary, with x, so Tm is going to increase in the linear fashion. Why? Because previously only we have seen this. Okay. Now this is the Tm variation. Tm will increase. We know that Tm is going to increase, but how it will increase? It will increase in the linear fashion. Okay. Now Ts we want to know. Till now there was no mention of Ts, and now we will see how Ts is varying. So from we know this relation, Q is equal to H into Ts minus Tm. We know this relation, H equal to Q is equal to H into Ts minus Tm. Now already you know that Q is equal to constant. This you know, H equal to constant. What will be this difference? If this is constant, definitely this difference must be constant. So Ts minus Tm is a constant thing. Now when Tm is increasing linearly, and if this difference has to remain constant, so Ts will also be constant linearly only. Ts will also be increasing in a linear fashion. Why? Because this difference has to be constant. So till now there was no mention of Ts, but now there is a mention of Ts, and from this relation we are very, it will be more than Tm. We are considering that the fluid is getting heated, so definitely Ts will be more than Tm, right? So this is our analysis of the first case where I have assumed that the flux remains constant, right? So some equations which I have written and I have circled, these equations you have to memorize, and you will be able to do all the problems based on this logic itself, by the logic that I have explained you. ठीक है? Any doubt till here? Any doubt? Now, moving towards the second case, constant surface temperature, and this is Ts equal to constant surface temperature, Okay, so here everywhere the Ts is constant. This is the TMI, mean temperature of the fluid at inlet, and this is TME, mean temperature of the fluid at exit. Okay. Now, what do I want to see? What do I want? Ts is constant. What do I want to find? I want to find that okay, it is increasing, temperature will increase, but how it will increase, that is our purpose, that is our intention. Okay. So what I will do in this case, I will analyze a vary at any distance x, I will analyze the segment in a vary. When something is varying, I always take the help of integration. I will study the heat transfer in a very small dx portion. So let's say that here the temperature of the mean temperature is Tm. So somewhat at here it will be Tm plus dTm. Some slight increase in temperature of the fluid is taking place, and it is Tm plus dTm. Okay. And this is the dx portion where I am going to analyze. So if I ask you what is the heat supplied, what is the increase in heat, what is the increase in temperature of the fluid, it is dTm. So how much energy the fluid has incurred, so I can say that it is m dot c and dTm, okay. So someone, when increase in fluid energy is taking place, so someone must transfer. Who is transferring? The pipe is hot, so pipe will transfer the energy. So for this dx, how much energy is being transferred? For this dx, how much energy? So h dA, h into dA. Why dA? Because elemental area we are considering. H dA and del T I can write. H dA and I can write del T. So del T के जगह पे I can write surface temperature minus Tm. Del T के जगह पे I can write this. Very good. So H. Now in place of dA, you know that what is the area? What is the area? It is pi d into dx. Pi d into dx distance, and this is Ts minus Tm. Okay. These two must be same. Okay. So H pi d dx into Ts minus Tm is equal to m dot c dTm. Okay. Now see one thing. Can I write d of Ts minus Tm? Can I write d of Ts minus d of Tm? So d of Ts is a constant, Ts is constant, so dTs will be 0. We are left with minus dTm. So d of Ts minus Tm, this I can write as minus dTm. So in place of dTm, this is h into pi d dx into Ts minus Tm. Ts minus Tm is equal to m dot c, and in place of this dTm I will be writing minus this minus Ts minus Tm, minus d of Ts minus Tm. So this minus is not looking good over here, so what I will do, I will take it somewhere. This minus is not looking good, so let me take it here, but you know that how the minus is coming. Okay. Check. So h into pi d dx by m dot c, and minus I am taking it on the left hand side, is equal to d of Ts minus Tm by Ts minus Tm. Now Tm is the variable there, Tm is the variable here, so I can very easily integrate. I can very easily integrate. ठीक. So let's say I want to see the variation, so 0 to x I am integrating. I want to see the variation, so 0 to x I am integrating. Okay. And here at 0, at x equal to 0, the temperature was Tmi, and at x equal to, at any x, the temperature, let's say, is Tm. So all these things are constant, so it will be minus h pi d by m dot c x. So it will be ln Ts minus Tm, ln Ts minus Tm. So between Tmi and Tm. Okay, so I am writing in the next page, minus h pi d m dot c x is equal to ln. Now what is the variable? Tm is the variable, so in these limits will be substituted in place of Tm. ठीक है, कोई बात नहीं. So ln Ts minus Tm by Ts minus Tmi. Okay. So log a minus log b, log a by b. Log a minus log b, so directly I have written log a by b. So the purpose of this analysis was just to show you that how the temperature is varying. If I ask you that how the temperature is varying, so I am not going further. From here only I can say that how Tm is how Tm and how Tm is varying with x. Okay. Others, as far as I can say, Indian authors' books are good for numerical practice. For conceptual and easy understanding, you can, I've read the question, others, don't worry. For easy and conceptual understanding, and for very, coverage wise also, Cengel is good. Cengel you can refer. I will recommend Cengel, keep Cengel with you. Keep Cengel with you. Read the concepts for the conceptual. For concepts, foreign author books are very good. That being said, keep Cengel with you. Cengel will help you. It's very easily written. And for the numerical practice, you can refer R.K. Rajput. Okay? And don't go for many books. At this stage, don't go for many books. Fix one book, learn concepts from there, and for practice, you can refer 1 or 2 books. I hope that helps. Okay. Cengel is good for concepts. Cengel is good. So now how the temperature is varying? How the temperature is varying? So I can say that temperature is varying logarithmically. Logarithmically. ठीक है? Logarithmically. So if I have to plot if I have to plot the Ts and Tm, how will I plot? So I can say that Ts is constant. Ts is constant. So how is Tm varying? Tm is varying in logarithmic fashion. So it will be something like this. Ts is constant and Tm is varying in a logarithmic fashion. So I will represent in this way. ठीक है. So we have discussed two cases. First case was what? First case was, I'll just quickly brief you what we are discussing. Forced convection through pipes we are discussing. I told you that this is the general expression. That we have got. There we saw that at one time H is always constant, at one time both cannot be constant because Tm is varying. So once we will make Q as constant, once you will make Ts as constant. So case 1, constant heat flux, and when we analyzed it, we arrived that Tm is increasing, Tm is increasing, but how is the mode of increase? It is increasing in a linear, sorry, where it is gone? It is increasing in a, where it is gone? I don't know why it is not coming, but ठीक है, कोई बात नहीं. So what we did that it is increasing in a linear fashion. Second was constant surface temperature, and there we saw that we did the analysis and it is increasing in a logarithmic manner. Okay, here it is. Once it is increasing, this is the case 1. And in case 2 it is increasing in a logarithmic manner. Yes, others I have replied. I have replied others for concepts. I think Sengel will be good. You can refer Sengel. There are many books in the market, but keep Sengel with you. Very easy explanation is given in the Sengel. Okay, Sengel book hai. And for question practice, you can do any, you can follow any book, but at least please cover the PYQs at least, and you can cover any standard book. Rajput will be good for numericals. ठीक है. So my dear friends, these two are the cases of forced convection through pipe. Now, one very important concept is that for fully developed flow, your H is constant. For fully developed flow, your H is constant. ठीक है. So what is Nusselt number? Nusselt number is H LC by K. LC in this case will be diameter, so HD by K. So K is constant, D is constant, and for fully developed flow H is also constant. So can I say that Nusselt number is also constant? फिर से बोलता हूँ, again I repeat, for fully developed flow the concept is H is constant. H is constant. So what is Nusselt number? H LC by K. LC for internal flow of the pipe you will get to be diameter. So HD by K. So diameter is constant, K is constant, H for a fully developed flow is constant. So can I say Nusselt number is constant for a fully developed flow? Yes sir. And it will have values 4.36 and 3.66. 4.36 for constant heat flux condition. Constant flux condition. And what is 3.66? It is for the second case, that is the constant Ts. Constant Ts, that is surface temperature. First case में Nusselt number is 4.36, second case में Nusselt number is 3.66. This concept you people are able to understand? This concept you people are able to understand? Okay, now all these discussions, whatever we have done till Nusselt number constant, this Nusselt number remains constant. For what? For laminar flow. For laminar flow, this Nusselt number remains constant. This Nusselt number remains constant. Okay, this Nusselt number remains constant for laminar, for laminar, for laminar. Now for turbulent flow, for turbulent flow, there is an equation. There is an equation that I am writing, and please note it down. 0.023 Reynolds number to the power 0.8 Prandtl number to the power n, where n is equal to 0.3 for cooling and n is equal to 0.4 for heating. And this equation is known as Dittus-Bilter equation. Dittus-Bilter equation. Now, what is Dittus-Bilter equation? It is for the turbulent flow in pipe. It is for the turbulent flow in pipe. Turbulent flow in pipes. ठीक है? Okay. So till now we have discussed all the concepts of forced convection. Forced convection, any doubt? Forced convection, any doubt? Forced convection we have started from yesterday. Yesterday I covered the flat plate. Today I have covered the internal flow through pipe. ठीक है? This much concept if you know, you will find that very easily you are able to do most of the questions. That being said, I will do the important PYQs also over here, but as of now I am focusing on the concept. ठीक है? Concept wise we are covering, and now we will see what is the concept of free or the natural convection. Okay, others, you are saying fluid dynamics, IC, refrigeration, power plant. See, RAC के लिए आप CP अरोरा रेफर कर सकते हो. CP अरोरा is a very renowned and very good book. Only one book RAC में, CP अरोरा. ठीक है? Power plant में you can refer PK Nag also. PK Nag you can refer power plant में. It's a decent book. It's a decent book. IC इंजन में V गणेशन आप रेफर कर लो. IC इंजन में V गणेशन आप रेफर कर लो. V गणेशन. So RAC के लिए CP अरोरा, IC इंजन के लिए V गणेशन and पावर प्लांट के लिए PK नाग. Bansal I didn't, to be honest, I didn't follow Bansal. Bansal I didn't like. Bansal I didn't like for fluid mechanics. Concepts are not given in a very good manner. For fluid I will not recommend Bansal. If you are understanding then very good, but fluid के लिए Bansal I didn't like, to be honest. Bansal fluid mechanics के लिए Bansal I didn't like, to be honest. ठीक है, I will do one thing. In this, I'll do one thing. Others, Anuj, I will do one thing. In this lecture, in this particular lecture, after some time, I will write down all the best books for, which you should refer. Okay? After some time, in this lecture, in this particular lecture itself, in the comment section, I will leave all the important books for GATE. ठीक है, Adarsh and Anuj, and whoever is seeing, for the GATE, I will list down all the important books for all the subjects. ठीक है, in this particular lecture. As of now, let us focus on concepts. ठीक है. Okay. Now, my dear friends, let us discuss free convection. free convection let us discuss, or natural convection, free or natural convection. Now see one thing, why does free or natural convection takes place? How does free or natural convection takes place? It takes place due to density difference. If in one word, if someone asks you how or why free convection takes place, it takes place due to density difference which creates buoyancy force, and this is responsible for your free or the natural convection. ठीक है. Now before I explain the mechanism of natural convection, before I explain the natural convection, before I explain the concept of natural convection, there is an important term, which is coefficient of volume expansion. Coefficient of volume expansion, and that is beta. Coefficient of volume expansion, that is beta. What is beta? Beta is change in volume with respect to temperature at a constant pressure. Suppose you are heating the air. When you are heating the air, so there will be change in volume. Suppose fluid is there, when you are heating it, there will be change in volume. So what is the change in volume with respect to the temperature at constant pressure? This thing is known as coefficient of volume expansion. And for ideal gas like air, this beta is given by 1 by Tm. This beta is given by 1 by Tm, where Tm is the mean temperature. In Kelvin. So I will explain you what is mean temperature, but as of now just focus on what is beta. Beta is the coefficient of volume expansion. अब देखो, what is beta? Beta is, just now you have studied, 1 by V del V by del T at pressure equal to constant. Now mass equal to constant, you know, mass can be written as rho into V is equal to constant. If you take the differentiation rho into V, so differentiation of constant, it will be 0. So what I can write? V into d rho plus rho into dV is equal to 0 I can write. So what I can write? dV by V is equal to minus d rho by rho. So over here the same expression can be written up, dV by V hai, dV by V, so I can write minus 1 by rho and d rho by dt at pressure equal to constant. I can replace this by this. Okay. So later on we will, both these equations are same, on one I have written volume and in one I have written density, and later on we will use this equation. Okay. Now my dear friends, assume that I will try to explain you, see, I will try to explain you, correct others, correct. Very good. Now I will try to explain you one thing. Suppose I'll try to explain you one thing. Now see that this is a flat plate. This is a flat plate, and suppose that this is hot. This is a hot plate and it is maintained at Ts, and ambient is somewhere over here. Ambient, this is the ambient temperature. Now what will happen? This is a flat vertical plate. Let's say its length IF, its predominant length is L. Now when it will come in contact with this, it will get lighter, and when it will get lighter, it will go up. When it will get lighter, it will go up. So suppose that here is near to the plate, here is one fluid element. This we are trying to analyze. Near to the plate, one is fluid element, and we are trying to analyze. We are trying to we are trying to analyze this. So can you tell me what are the forces which are acting on this? What are the forces that are acting on this particular fluid element which is near to the plate? Which is near to the plate. Now see, when it is going up, that means someone must be pushing. When it is going up, someone must be pushing. That someone is your buoyancy force. And when it is going up, there will be viscous force within it. When it is going up, there will be viscous force. So viscous force will try to oppose the motion. When something is going up, there will be friction between the layers, and that means viscosity will come into picture, and therefore it will act in the opposite direction. Okay, so viscous force bhi lagega. This is T infinity ambient. So viscous force bhi lagega. What is viscous force? Mu into VL. Mu into VL. Okay. Okay. Now when something is in motion, inertia force bhi lagenge. When something is in motion, inertia force will also come into picture, and inertia force will also oppose. Inertia force will also oppose. So inertia force will be rho v square L square. Rho v square L square ये भी oppose करेगा. It will also try to oppose. So majorly three types of forces, three forces will come into picture. That is viscous force, inertia force, and buoyant force. Acha, buoyancy force, what will be there? The buoyancy force, whatever is taking place, it is due to density difference. So del into rho, density difference G, rho G, and V, volume. So volume के जगह पे I can write L cube. Again I repeat, the buoyancy force, what is taking place over here, it is due to what? In convection, whatever buoyancy force is taking place, it is due to what? Due to pressure difference? No, it is due to density difference. Not due to pressure difference, it is due to density difference. In FM, in fluid mechanics, whatever buoyancy force you have studied, that is due to pressure difference. But here, whatever force, whatever buoyancy takes place, it is due to density difference. So I have written del of rho, rho GV. Rho GV hota hai force rho GV. So del rho G into V, and in place of V, I have considered L to be predominant direction. I have written L cube. So all these three forces comes into picture when you are analyzing what? Free convection. You are analyzing what? Free convection. So now Reynolds number will not come into picture. In place of it, there will be one non-dimensional number, a separate non-dimensional number which is there, and that is known as, you everyone know, Grashopp's number. So I will give you an idea how Grashopp's number is there. So what is Grashopp's number? Grashopp's number. Now see, using these three forces, how many forces? These three forces only Grashopp number will be made. So your Grashopp's number will be buoyancy force into Fi by Fv whole square. This is the formula for Grashopp's number. Okay. Now what is Fb? What is, you know, Fb? It is d rho G into L cube. ठीक है, d rho. Now tell me one thing, from your concept of this coefficient of volume expansion, d rho, this is d rho, can I write like this? Minus beta rho dt. Can I write like this? Okay, minus beta rho dt. So I am using it over here, minus beta rho dt G into L cube. Now minus, you consider the mod sign, ignore the minus. Ignore the minus and simply consider the positive. So beta rho delta T G into L cube. Beta rho delta T. So in place of Fb, I will substitute this, beta rho delta T G L cube. Beta rho delta T G L cube. What is inertia force? What is inertia force? Rho L square V square. Rho L square V square. And what is viscous? Mu VL. Mu VL का whole square, mu V square L square. Mu VL का whole square, mu square V square L square. ठीक है, very good sir. So anything is cancelling out. So v square you eliminate, L square you eliminate. So what is left? G beta delta T rho square L cube by mu square. Acha, mu by rho, you know kinematic viscosity. Mu is dynamic viscosity, rho is density, that is kinematic viscosity. So what is the formula for Grashoff's number? G beta delta T L cube by nu square. This is the formula for Grashoff's number. This is the formula for Grashoff's number. Yes, others correct. Others correct. Others correct. Correct. Buoyancy force upward vertical. Correct. Upward. Correct. So G beta delta T L C cube. Correct. Yes, others, you can follow the lectures. That is not an issue. You can follow the lectures. You can follow it. No issues with this. Yes. Okay. So what is Grashoff's number? Grashoff's number is G beta delta T L cube by nu square. Now what is LC? LC is the characteristic length. LC is the characteristic length. What is Grashoff number? G beta delta T LC cube by nu square. LC is the characteristic length. Characteristic length. Now I have told you what is beta. Beta is 1 by Tm. What is beta? Beta is 1 by Tm. So for example, this is a flat plate. It is having a temperature Ts and the ambient temperature is T infinite. This is the flat plate, its temperature is Ts and ambient temperature is T infinite. So what will be the mean temperature? Mean temperature will be Ts plus T infinite by 2. Ts plus T infinite by 2, this is the mean temperature. But please note it down that this is in Kelvin. This is in Kelvin. This is in Kelvin. Strictly it should be in Kelvin. Strictly it should be in Kelvin. ठीक है? So this is the concept. This is the concept of free convection, and you know that over here in free convection, in free or natural convection, your Nusselt number is a function of C times Grashoff's number into Prandtl number to the power m. ठीक है? Grashoff's number into Prandtl number to the power m. So C and m will have different values, and it will be given in the examination that what values it is actually. Based on question, they will give you what is the C and m values, and the product of Grashoff's and Prandtl is also known as Rayleigh number. So that is there. So what is the difference in forced convection? In forced convection, the Nusselt number is a function of Prandtl number and Reynolds number, but over here it is a function of Grashoff's number and Prandtl number. Udhar Prandtl and Reynolds, here Grashoff's Prandtl. So Reynolds is replaced by Grashoff's in free convection. And what is the formula? The formula is this. What is the Grashoff number? G beta delta T L cube by nu square. I have derived it. What are the predominant forces? The predominant forces are 3 that I have also mentioned. Okay. So today we have discussed the concept of internal flow through pipe. 2 cases I have taken, that I have told you how the variation is there of temperature, and now I have discussed the free convection. So I can say that at least 70-80% of from where questions can come, all those expected concepts from the convection we have discussed. Conduction already we have discussed. Conduction series already it is done. This is the convection. 2 lectures I have taken for convection, and if you follow these 2 lectures itself from yesterday, you will see that most of the questions that we are doing it is coming from these concepts only. ठीक है, this is the, remember the series name, it is most expected concepts, most expected concepts. So these are the most expected concept from where if you take any PYQ, past 10 years if you take PYQ, you will feel that most of the concepts are coming from these only which we are discussing in the class. Still, if you want any specific concept to be discussed, so comment section mein you can you can write down that sir please teach this concept, so I can especially if you want, so I can teach that concept also. ठीक है. So convection here we are closing it, and next class, conduction already done, convection I have discussed. Next class mein I will take up the concept of radiation. ठीक है. So all the important concepts, that is radiation shields, view factor, all the types of radiation, all the types of heat transfer, what is emissivity, spherical emissivity, all those things, what is the concept of solid angle, all these concepts we will discuss in very much detail. So in case you like, in case you find the videos useful, please like and subscribe, share it with your friends. Any doubt you can ask in the comment section, and as I promised that after some time in this video itself I will be leaving the list of important books for the mechanical, right. So let us end the session here itself. Any doubt you can leave it. Till then, please revise, study, it is near. Take care, God bless. Jai Hind. Bye. I am ending the session.